Good morning. Uh, I'm Farrokh Mistree,
I'm Janet Allen.
and today we are going to see the conversation on design engineering 4.0 for realizing evolving cyber-physical social systems. Much of the work is based on a paper that is to be published or should be is online already, and it's titled "Design Engineering in the Age of 4.0."
Industry 4.0.
Industry 4.0. So this conversation series, every week we are going to have a conversation. So the idea is to seed the conversation and for people to then enter into a dialogue in terms of what we can do together, how we can do things together. The intention is to establish collaboration, not just between us, but between people who join us on a regular basis so that uh, we can spin off collaborations with various people around the world. So the research theme for the Systems Realization Laboratory at the University of Oklahoma is evolving cyber physical social systems. And this is our research theme for the next 3 years. Every 3 years, we change our theme. And so this is the theme that we are focused on. So we are in the exploratory stage of saying, this is what we want to do. How can we define it? So input from people, from various people, and what people are doing is very, very helpful. So we want to get a better understanding of what evolving cyber-physical social systems mean, because it means different things to different people. And more importantly, the questions worthy of investigating. And so with that in mind, we have initiated a conversation series that we are part. This is the second of the series that we are talking about. So we plan to invite people to initiate a conversation anchored in their research interests, and we expect all to be richer as a consequence of this conversation. So if you have suggestions as to who you'd like to invite or hear from, or you'd like to give a talk, let us know, because it hasn't been fixed. It's organic. We are developing it as we go along. So our aim today is to foster dialogue with a purpose. The important thing is with a purpose, and we told you what the purpose is. The purpose is to seek collaboration. The purpose is for each of us to be richer by listening to the other person and listening to the dialogue that takes place. Between the SRL community, at OU community, and friends, and to offer a way forward for collaboration. So what's the context? There's a huge amount of noise, some good, some hype about Industry 4.0. So what we want to do is to go back to the original idea of what is Industry 4.0, and in that context, frame our discussion. What we've seen is in this hype, there are people who are doing things, and then I say, hey, guess what? What we're doing is Industry 4.0, and it doesn't make sense. It's just old stuff in new bottles. So Industry 4.0 is a comprehensive transformation of the whole sphere of industrial production through merging of digital technology and the internet with conventional industry. This was launched in 2014, and Angela Merkel is the person who you could give the biggest credit to, because she came along and said, for Germany to continue as a manufacturing power, what needs to be done? I recognize that there's a revolution being brought about by information technology. How can we leverage it? And so Industry 4.0 is tied very closely to the notion of manufacturing. Okay? It is not, and people have come up with other things like agriculture 4.0, stuff like that. But it's important to recognize that the principles in Industry 4.0 are foundational, only foundational to other things that take place. And so you cannot directly go along and apply Industry 4.0 and say, okay, now I'm doing agriculture 4.0. There has to be a transition. So in our case, we come from the design perspective. So the American Society of Mechanical Engineering has this to say about it. The combination of digital processes such as the Internet of Things, automation, robotics, and additive manufacturing has a disruptive impact on mechanical engineering design. Not only do engineers need to redesign processes and operations to accommodate these new advances, Industry 4.0 impacts how they design products for increasingly smart manufacturing facilities. In other words, ASME has recognized that smart manufacturing needs to be tied somehow to design. And we are going to explore this notion further. Now, by way of background, what do we mean by a digitally transforming enterprise? A digitally transforming enterprise is characterized by the integration of digital technology into all areas of a business, fundamentally changing how it operates and delivers value to customers. It necessitates a cultural change that requires digital transforming enterprises to continually change the status quo, experiment, and get comfortable with both success and failure. So what we're looking at here is not just saying I'm already doing it. What we are suggesting is that here is an opportunity for us to think in terms of how to transition from what we are doing to a new state. And the new state is when we are looking at digitally transforming enterprises. So what is the internet of digitally transforming people? The pandemic has shown us that, hey, guess what? Remotely, we work and we can work from our offices and we can make things happen. So we are digitally transforming people. So what we have to be as academics, our graduates who are digitally connected constitutes the internet of digitally transforming people and must know how to adapt to change. Sir Charles Darwin is reputed to have said, it is not the strongest of the species that survive, nor the most intelligent, but the ones most responsive to change. Now, what does that mean? Most responsive to change means adaptation. So when somebody comes along and says, I've got this and it is Industry 4.0, I don't buy it. Why? Because I want to see how what they have already done is transforming and fits into this notion of a digitally transforming enterprise and people. So this is evolving. Industry 4.0 is not fixed in stone. It has to evolve. And the whole notion here is that we evolve as we proceed. So now we come along, and here's a quick thing, and I credit it to Zhenjun Ming, who's worked with us over the years. Value creation in a digitally transforming enterprise. So let us take a look at what is in this picture. They're humans, there's a cyber system, and there's a physical system. The cyber system deals with algorithms and computing. The physical system provides data. And the data is never sufficient to make a complete decision because we're looking at incomplete information. So human judgment is required. And this is what is called the industrial brain. Now, let us take a look at the cyber side of things. In the cyber side of things, people talk about the digital twin, the digital thread, and cloud computing. These have very specific meanings. And I think as we go forward, for our community, we need to define what we mean by a digital twin, what we mean by a digital thread, what we mean by cloud computing. I think those definitions, by the end of the semester, it would be very nice to have these definitions as to what we subscribe to. Now, on the other side, the physical system, there's automatic control. That's material, machine, and product. So that happens. It's through this that we get data. It's through this that we're able to deal with algorithms and computing. When these two things come together, we can think in terms of smart manufacturing. And what we're looking at in a digitally transforming enterprise is not just the cyber physical system, but the human coming into the loop because judgment is required. Why? Because what we are doing here in the system, we cannot model the entire system. We don't have all the information. And since it's evolving, we cannot predict the future with great accuracy. So there are two domains that we are looking at. One is automatic control, and there's a lot of work that has been done and can be done in the area of automatic control. And the other is the notion of decision support. And today, Janet and I are going to talk about, focus on decision support, where we have the designer, the manufacturer, the supplier, and these are networked and distributed all over the world. So what are the ramifications of this picture that we've taken you through? Industry 4.0 is foundational to smart manufacturing. And design engineering 4.0 calls for a cloud-based hub to support distributed open innovation of product and process. Because remember, ASME has talked about product and process in advanced manufacturing and a digitally transforming workforce. And if we do this, that's the starting point to sustain a cyber physical social system. So that is when we can think in terms of manufacturing being part of a cyber-physical social system. So at a high level, what are the research opportunities in design engineering 4.0? So we're going to, Janet will take you through and give you a better definition or a closer definition of design engineering 4.0. So what is design engineering 4.0? It goes beyond conventional engineering, design three-dimensional space to a four-dimensional cyber-physical social service space comprising of four perspectives, namely human, systems, cybernetics, and business. So design engineering goes beyond the notion just the three dimensions, but goes into the four dimensions, that is human, systems, cybernetics, and business. Cybernetics from the control side, business from the making money side, human from the judgment side, and system from that which we have put together. Now, if you look at the human business side, the social side comes in. Why? Because we are doing it for people. If you look at the human and system side, the physical side comes in. What is it that we are putting together? That's the machine and things like that we are putting together. If you look at the system and cybernetics being controlled, we are dealing with the cyber side of the system being controlled by the computer and the systems we put in place. So who, what, where. If you're looking at business and control, we're again looking at the service side. We look at the service side here in saying, how do we provide the service for various activities? In the inner circle, we have perspectives. So in the human system perspective, there's conceptual design, functional requirements, detailed requirements, etc. These are opportunities for universities to explore and say, aha, JKL University is going to look at human system side of things. SRL to OU is going to look at such and such. University at Buffalo is going to look at such and such. So this way we create a consortium of universities that say, hey, guess what? These are the things that we're going to look at in the inner circle and define them for ourselves. The outer circle represents what industry needs. For example, digital health modeling, smart and connected communities, emotional design, et cetera, et cetera, et cetera. This is what industry is looking for. This is the fundamental research that we're able to do at a university in the context of what we have shown out here. So now, Janet is going to start you off with engineering design, how it is defined, and then how it transforms to design engineering 4.0 in the context of industry 4.0. Go ahead.
So this is where we are now as far as engineering design is concerned. We've been thinking about designing systems, components, or processes. So all of these different things have been something that we've considered in the past, and we're going to need to consider much more in the future. We have argued that design is a decision-making process. We talked about decision-based design, and we've noticed that it's often iterative. In other words, it's not one big decision and you're done. You have to keep thinking about it. But in this process, you integrate science, mathematics, computing, all of these things. You can think of these as resources which you need to apply to a objective. In other words, these things are services you can use to affect your goal or accomplish your goal. So we can think about fundamental elements of a design process as objectives, criteria, synthesis, analysis, construction, testing, and evaluation. These are things that we always think about when we have thought about engineering design. So let's think a little bit about how we got to where we are as far as the ideas of design are concerned, and how we have gotten to the ideas of industry also. So we said that we're talking about, have been talking about Industry 4.0, and you notice that this evolved from mechanization, from steam power to electrification, Industry 2.0, 3.0, automation, digitization, and so forth. In Industry 4.0, we're talking about smart connectivity, integrated intelligence, IoT, human cyber physical systems, cloud manufacturing, and so forth. All of these things we can think about as Industry 4.0. At the same time, we thought about design evolving, functionality, volume, craftsmanship, so far. These are things that were started out to be the realm of design. Then we began to think about design engineering 2.0. We were still thinking about cost and speed, standardization, interchangeability. We've added that information onto design engineering 1.0. Now in design engineering 3.0, we're thinking about functional, effective, cognitive needs. So ergonomics comes in a little bit, physical, digital service, volume, low, agility, important, cost, speed, quality. We're thinking about that. We've thought about DFX, including design for manufacturing, design automation. So this makes up design 3.0. So when we talk about design engineering now, we're talking about a user experience and a personalization. These things are becoming important. Mass customization carried to the extreme. Smart and connected product ecosystem. So not just a single product, but a generalized ecosystem of products. Mass customization, business models, value chains. So it is not only the product, but how it contributes to the value of the company. So we can go back to our ideas about how you integrate the manufacturing process, the business model, and the product all together to make value for the company. Open innovation and co-creation and data-driven decision-making. But further, in the future, we believe that Industry 4.0 and design engineering 4.0 are inevitably going to be inextricably linked. In other words, it will not be designed for manufacture. It will be something that you have to consider immediately up front, and you need to consider all of these different things as Industry 4.0 as you design and proceed. So we're thinking about design engineering 4.0 in this talk.
When we look at evolution, you will see how things have evolved. Design, it's a dictatorial thing. This is how customers say, this is what I want. This is for customers, with customers, and by customers. So what we are looking at here is co-creation. This is a very important aspect. And increasingly governments, people, communities say, hey, guess what? You have to take into account the people who are going to be affected by what you do. And so this is a major consideration. So it's no good just coming along and saying, I'm doing Industry 4.0. Here is my algorithm. I'm going to make it work. We have to think in terms of how we are going to co-create this so that what we design becomes acceptable.
Okay, so we're thinking about design engineering 4.0, and we're thinking about the human cyber physical view of systems realization ecosystem. That is, how are we going to accommodate the drivers of Industry 4.0? So we'll talk about what those drivers are, and we want to provide an open ecosystem for the realization of complex systems. So that is where we begin to think about computer platforms and so forth. So we want to integrate digital threads, digital twins throughout the product design development and fulfillment lifecycle. And we want to accommodate diverse and rapidly changing technologies. It's clear that things are changing rapidly. How do we deal with that? So we want to have a mechanism to facilitate the creation of new opportunities to design products, processes, services, and entire systems, ecosystems and other systems, and even systems or systems are some of the things that we would like to accomplish for design 4.0, engineering 4.0. Can I have a copy? Thank you. So Farrokh, a few minutes ago, talked about the some of the components or the important parts of what we think of as design engineering systems. We're thinking more about how the human interacts with our products and services and systems. Obviously, business is a big driver because finance, economics is very important. The computers, systems, cybernetics, and controls are making things much more rapid, efficient, and convenient, as well as improving processes. And entirely, we have to begin to think about systems. So we're thinking about all of these things together as design and engineering 4.0. Between business and human, you can think about the Internet of people. Between business and cybernetics, Internet of commerce. So people haven't talked a lot about this, but this is happening right now, and it's something that we can manage. Internet of things between cybernetics and systems, and Internet of services here between the human and the system. So here we're thinking about design of human cyber physical systems. Here, design of smart sensing and AI technology. Design of strategic engineering. In other words, how we want to move forward. This is where we're talking about evolving systems and how you design an evolving systems, and design for user experience here in this section of our circle. So this is what we think of as design engineering 4.0, and the human cyber physical view of the systems realization ecosystem is encapsulated in this circle.
This is a great opportunity for all of us to say, hey, we are interested in such and such. For example, JKL University is evolving. Centurion University is evolving. John Hall, he has a research program that is evolving. Anand Balu has a research program that is evolving. In which space do I want to place my research program? In which place do I want to place my university strategically with the faculty so that we are able to proceed in a systematic and organized way, collaboratively to move this forward?
So here are some ideas that we have drawn from the existing Industry 4.0 paradigm. So we need to think about what the key principles of digital transformation for Industry 4.0 are. And we can think about the strategic areas of design. So think, instead of individual products, begin to think at a higher level and think about the artifact, the process, and the human. So it is both human and society we're thinking of here. So now we think about the key principles we are building on. So connectivity, visualization, and interoperability here. Big data, everybody's heard about that. Information transparency. So security and transparency, of course, are important. Decentralization, modularity, and interactivity are here. Service orientation and networked resources are here. So these are some of the things that we can look around and see are happening now. If we move over here and think about how they fit into our strategic areas of design, you can think about, in the terms of the artifact, smart and connected products, digital twins and intelligent design automation, and product servitization and anything as a service. Now, we've begun to talk about various different kinds of services, and it's clear that services are being defined more and more broadly. And so anything as a service is what you're seeing. So this is something that the computer scientists have begun to think about, and it's a useful concept when you begin to think about platforms. Okay, back to the strategic areas of design. Now we're thinking about design processes. So instead of thinking about hierarchical design, we can think about end-to-end digital integration. So it is not only hierarchical or multi-scale sorts of things. It is end-to-end digital integration of processes, and you define where the ends are. So is it the end at a manufacturing line? Is it an end at the particular business opportunity that you're checking? Is it an end in the whole society? So you have to think about how you're integrating things and how much you're integrating. Of course, data-driven design is something we've talked about a lot, and extend supply chains and agile collaboration networks. This is something that, again, is grown out of industrial engineering for sure, supply chains and collaboration networks. And so then, to enable all of this, So this is in service orientation and networked resources. We're thinking about platformization. So how you can enable this to be convenient for designers and others. Coming back to the key principles of data transformation for industry and the strategic areas of design, you can think about what's happening with the human. So what happens when you are designing things, personalization, but yet maintaining some sort of a customization activity. You can also think about how the human will help you create or identify useful products. So there's co-creation, crowdsourcing, and other sorts of activities that allow the human to have greater input into what is being designed. Do you want to add something?
Yes. So, for example, Dipankar is at Centurion University, and Prakash is at JKL University. They could come along and say, "Guess what? Dipankar says I'm going to deal with agriculture 4.0. For agriculture 4.0, which is growing crops, particular crops at a particular time, etc. Precision agriculture. We need to have a platform that will allow the farmer to go along and sell his products and make money and stuff like that. So JKL University can say, hey, guess what? We are interested in putting this platform together. So Dipankar at Centurion University could be developing the technology for smart agriculture that could feed into what is happening at JKL University. Ashok Das with Sun Moksha is interested in what's happening on the ground in the villages that he's working on through the introduction of new technology. He could be working with both Dipankar in terms of developing sensors for smart agriculture, and with Prakash to provide data and information for his platform. So this is how one can look at it and say, this is how we can collaborate.
So those of you that are in universities, you can think about education feeding into this area. So you would,
go ahead.
Okay, you would think about the things that students need to work with faculty, possible platforms so that you can share information across universities, and various other products and services, anything as a service for education. So this is something that can be applied in many different areas. Okay.
And Anand, you're writing a proposal right now for NSF. You can use something along these lines by way of providing context and saying, this is where I'm going, this is where I'm starting, and this is where I wish to go with my career.
Okay, so another way of putting what we've talked about, these are some opportunities we see that will take the field forward, that are going to be something that you want to pursue or can pursue. So, but many of them, of course, are challenging. So you can think that there is an opportunity here for smart and connected products, end-to-end digital integration, whatever that means in whatever field you're looking at, customization and personalization, data-driven design, and even design with synthetic data, which you don't quite have information about yet. Digital twins and intelligent design automation, how this can feed into your possibilities for designing. And this is something that is being done right now, in my opinion, very poorly. People have just said, okay, I'm doing optimization now, and I'll just call it a digital twin. Digital twins are something on beyond that, which encapsulate a great deal of information about the object that the twin is representing. Okay, extended supply chains and agile collaboration networks. So this is an important thing, going to be important for business. So how do you incorporate everything into your collaboration, into your success as a business? Open innovation, co-creation, crowdsourcing. We've talked about open innovation. Many of you have taken Farrokh's open innovation course. Product servitization and anything as a service, fine. That's very, very necessary. And then platformization for the sharing economy. So these last two things go together. How you're going to make a platform with products in it that can be used for services anywhere.
So Lynn is going to start a faculty position in the fall, and she will be writing proposals to get funding, and her proposal will go to, is likely to go to NSF as a career proposal or as a standard proposal. She's finishing her dissertation. In the I statement for her dissertation, she could touch upon these things and show how the work that she has done for her PhD will lead to advances in these directions. The same is true for Reza and for Rachel. This framework allows you to say, all right, for my PhD, what is it that I'm going to be doing or touching upon here that will allow us to move forward in design engineering 4.0. Haley is working at the intersection between qualitative and quantitative information to improve the quality of life of people that are at the bottom of the economic pyramid. Again, in your dissertation, your last chapter, your I statement could touch upon these things, saying how does what you do feed into one or more of these activities, so that when you get your faculty position, you could write write a proposal to the National Science Foundation or wherever. Amaninda, I don't know enough about your activities, so I cannot suggest things to you right now. During the summer, we can talk about it, and certainly during the discussion phase, it would be very nice. Hanbing and Jiahong, again, this is something when we start discussing, go into the discussion mode, I would like to hear from the three of you.
So obviously this is something that's going to be a challenge, but so challenges are good for people. So let's think about what the drivers and challenges are of design engineering. This goes back to the Internet of Services we talked about earlier. And it's based on the idea that technologies are changing, customer requirements and preferences are changing or evolving. Unpredictable and hard to manage disruptions will drive the future. So you begin to think about, this is the context in which we're working in. And so you need to think about what the requirements are to overcome these challenges. So we need to customize products to user requirements while producing products of 0 lot size. In other words, it is not mass production, but we're thinking about mass personalization as compared to mass production, and how you can trade these things off in a cost-effective way. Challenges you can think about are how to design products and systems that are resilient, sustainable, and can adapt to changing conditions, especially when the change cannot be anticipated at design time. So you can think about your cell phone. You've got a system that obviously you adapt software, change software, and can be good for many different generations. Then you can think about how you would develop standards for interfacing and using these entities and their digital twins across the entire ecosystems, from design to product realization. So this is going to be an essential part of making all of this happen, how you standardize things that will work together. Then we can think about digital twins of design variants, considered only during the parameter selection optimization stage, be used to respond to disruptions that affect production processes. In other words, what happens when there are disruptions, and how can you manage to use that effectively? If we move to thinking about the Internet of People, okay, here, what is going to be the drivers and challenges here that we see from looking up, from the bottom up? We see things like the distinction between physical and digital services will be blurred, okay, as Industry 4.0 technologies become prevalent. Individuals will play a dual role of creators as well as consumers. So you'll have the need for different things going on. Changing user preferences and the way users interact with the products and between themselves will be the main drivers of design engineering 4.0. And you can see what is happening, say, with the movement of everybody to interacting virtually, how user preferences have changed. And you can see that there are disruptions on the horizon. Many of these things will not be reversed. But the challenges we see, how we're going to foster innovation in this sort of a situation, and an ecosystem of innovation, because it's very seldom now that one person can come up with ideas and make them happen all by themselves. So consumers and design engineers must play a creative role in shaping the systems of the future. Also, we want to develop and maintain a workforce that can stay in tune with changing technological landscape. That means that our education system is going to need to change. Okay. What about the Internet of Things? We talked about network systems in the prevalence of IoTs will make design data easily accessible through the product lifecycle. So it is now not going to be a problem to find out what is happening to your product. So we'll want to design systems that will collaborate and improve product quality, process reliability, system agility, and sustainability. Of systems realization ecosystem will be the main drivers of design engineering 4.0. When I read this, I think about what is happening with the automated cars, the cars that drive themselves. So you can think about how important it will be for the cars not only to see what is going on in front of them, but with other cars in their field. And then how you can interact with larger systems, such as identifying where parking spaces will be or where there's traffic and so forth. So all of these things we see coming into the Internet of Things. The challenges we see. So we get information from everywhere, and they're diverse data streams and in real time. So we're talking rapidly, will aid decision making, how you can do all of this. Data mining techniques applied to big data are based on the premise that information is encapsulated in the data in some form. And since initial design iterations are based on actual data, is it possible to design systems where partial or no data exists? That's a really, really important one, because when you're designing for the future, a lot of stuff you don't know, and you're not going to know. It is not enough to walk up to somebody and say, in 5 years, what will your cell phone look like? Because people just can't think beyond, the next generation of things. Can one always build consensus when data streams do not indicate any reliable information or contain conflicting information? This happens all the time. And how do you decide what is the right thing in order to build on and make your decision? Synthetic data I've talked about can be created using the digital twins of the process used in the design process. Now let's think about the Internet of Commerce. Again, this is where money is. System design and productization is driven to a large extent by the necessity to make a profit. The challenges to be addressed are, how can design anticipate the many ways in which the product can be monetized? Again, think back about the first cell phones and where they are now. How would a designer have anticipated all of this? As a result of network systems and ubiquitous design and data sharing, cyber threats are no longer restricted to loss of privacy or the financial domain. One of the most urgent challenges is how can designers inoculate systems against threats when the nature of interaction between system components is unclear at design time. So this is a thing that we are seeing now with cyber terrorism. that's going on in the Colonial Pipeline and other places. So this is an important thing. Could we have designed the systems better so they're not susceptible to threats like this?
Okay. The notion of Internet of Commerce is emerging, and what one is looking at is a sharing economy. The phrase sharing economy also is emerging, and you may like to look it up in Wikipedia or on the internet, because this is what we are talking about. We are looking at a shared economy, and we are looking at people participating from all over the world, not located in the same place, but located at different places to make things happen. So now we come to what we are interested in the Systems Realization Laboratory at the University of Oklahoma. Janet and I are interested in mentoring the next generation of professors who are eager to learn how to create knowledge, archive knowledge, mentor others, and are recognized for their scholarship. So this clearly is our value system. We're interested in educating professors to go out into the world and change the next generation of professors. So our research thrust starts with a hypothesis. We hypothesize that all grand challenges are modeled as cyber-physical social systems. What is a grand challenge? A grand challenge has been put together by the National Science Foundation, by the National Academy of Engineering, by the Royal Society for Engineering in Britain, by the Indian government. So grand challenges have been given. What are some of these grand challenges? Food insecurity, water scarcity, quality of life for people, healthcare, etc. We are making a bold hypothesis that all grand challenges can be modeled as cyber-physical social systems. Now, to address these grand challenges, it cannot be done by technologists alone, or people alone, or government alone. It requires the symbiotic relationship between business, government, consumers, etc. So we hypothesize that public policy is foundational for addressing any grand challenge. Why? Because we have to deal with the change of human behavior, make that happen. We have to deal with people adapting, government adapting, industry adapting, universities adapting. How do we make that happen? That deals with public policy to address the grand challenge. So these are the two hypotheses. Hence, what we are looking at is evolving physical social systems to support policymaking. The key notion is that we perceive that the evolving cyber-physical social system can be comprised of several services to be modeled as a multi-echelon network. RESA is working on that, thereby ensuring the framework used to design, it is agnostic to the services embodied therein. So it's not just for manufacturing, it is not just for design, it is not just for a product, it's not just for a process. We have to think in terms of what are the services that are being offered by this, that are being embodied in this multi-echelon cyber-physical social system, so that the mathematics can be particularized to healthcare, can be particularized to defense, can be particularized to education or what have you. The potential applications that we are interested in our laboratory are rural development with Ashok Das, connected communities with Lee Song, monitoring greenhouse gases with Pechwan Kezampur, education with Shan Peng at Beijing Institute of Technology in China. So here we've listed out Zhenjun Ming, cloud-based decision support, rural development, Ashok Das, connected communities, Lee Song, sustainability, Pechwan, evolving cyber-physical social systems, Yelena and Anand, both of who are on this presentation. We are hoping that Lynn will get involved in this. We are looking forward to John Hall, who's represented by Haley, being involved in this. And then we are looking forward to building our capability in education. There are 4 foundational references that we want to bring to your attention. One is titled Architecting Fail-Safe Supply Networks. What allows us to do out here, what has happened out here is the following. We have a supply network where we want to optimize the flow between 2 points. A huge amount of work has been done in that. The second type of network design involves changing the structure of the network itself. That means we are putting together a new supply network. How do we create that network? A lot of work has been done in that. The beauty, what is embodied in this book, is that we show how you can do both of these things simultaneously. We can maintain the flow through the network and at the same time change the structure of the network simultaneously. To the best of my knowledge, this is the first and only group that is able to do this. What is not embodied in this book is uncertainty. How do we deal with uncertainty? That is covered by Anand Balu in his monograph, where we architect robust co-design of materials, products, and manufacturing processes that ties very closely to Industry 4.0. And in his chapter 7, he's laid the blueprint for how we model uncertainty and how we can take uncertainty into account when we have change, network change. So the integration of these two things is of extreme importance. Yelena, who is attending this webinar, she has focused on architecting network engineered systems for dynamic management. So when you have information information comes in instantaneously, or it also comes in, you collect it and then you can reuse it later on. Yelena, in her in this monograph, has shown how you can use information to dynamically manage the system. So here we have the multi-echelon network. Here we have putting in the notion of robust design, managing uncertainty. Here we have the notion of dynamic management of the system. And Zenjun, Ru and Anand, this is a monograph that should come out in the next 2 months. Architecting a knowledge-based platform for decision support in the design of engineered systems. So this is the platform that has been put together with the idea that it can be particularized for healthcare, it can be particularized for a product, it can be particularized for a process, it can be particularized for whatever we need to do, agriculture 4.0, etc., etc. Now, if you're looking at policy making for disruptive innovation, monographs 1 and 3, the one by the one on networks, fail-safe networks, and the one by Anand on robust design, deal with this. Monograph 2, which is the one on dynamic management, deals with this domain. Lin Guo, who is also on this call, she's finishing a PhD dissertation, and by the end of her dissertation, she will have contributed to how we can formulate and explore in an iterative fashion, and how we can do data curation. And we expect that Springer will publish this monograph in 2022. So with that, we come to the end, and we are open for questions for clarification and interest in collaboration and a dialogue in terms of takeaways, what is the value that you got out of this talk, what you see yourself contributing, what you see yourself doing, the imagery that has come forward to you, who you would like to hear next, what you would like to contribute next, etc. So with that, we're open for 25 minutes of this dialogue. Who'd like to start?
I think we overwhelmed them. Ashok.
Hi. Farrokh, on slide number 8, where you were showing the industry evolution and design evolution, what do the various arrows mean? Because in the end, you have bidirectional.
You're good.
Okay, so here's what we're thinking about.
Can you see it?
Yes.
All right,
Okay.
go ahead.
So it used to be that the designers were feeding information into industry. Okay, so industry 1.0, you'd make the design, you'd throw it over the wall, and industry would get it. Then people began to recognize that you needed to consider manufacturing in industry as you were designing a product. And in industry 3.0, it was more or less a 2.2 design for manufacturing here. Now we believe that things are going to be entirely integrated, so that the design things will come from design to industry, but also industry will say, these are my needs in a clearer way, and actually push the design process. So it's going to be integrated Design by customers, that's co-creation. So we are thinking that there's a greater merging here. And of course, it's not just industry. We're thinking about all different kinds of activities, again, agriculture or whatever. So a greater integration of design and the industry.
This is a great question, Ashok. And if you think back to when you were educated at IIT Kanpur, you were shown how to design stuff, and then it would be thrown over the wall for manufacturing. So that's where this single line comes in.
Yes.
Then what happens is, okay, so industry came back and said, oh, you idiot, you can't, you've designed some horrible stuff, we can't manufacture this, so you'd fix it, and you'd go back and say, oh, I'm sorry, okay, I fixed it. Then it came along and said, oh yeah, when you design, you take design for manufacturing into account. And so that's what happens. So that's where these two things, it's still separate streams. And these are separated in time. Now we are saying it is instantaneous. You have to communicate with the manufacturing facilities. You design for the manufacturing facilities available, particularly since we are looking at additive fabrication. Additive fabrication can be anywhere. The manufacturing can take place anywhere, and within a day or 2 days, the part can be sent to you. So the whole thing has changed. The time scale has changed.
And the abilities have changed. So additive manufacturing obviously brings a whole new realm of possibilities. And
Yeah,
there will be other
correct.
technologies.
Whether it is industry, industry could be anything, as you said. Any application that we are looking at and designing for it, the real-time feedback and back and forth is what has become the reality, right?
Yeah. Great.
Thank
Other
you.
comments?
Yeah, this is Dipankar. I want to share one of my experiences that might be really relevant to this Industry 4.0. Like we have a Dassault lab which provides all Dassault tools. So we have CATIA, we have Simulia, Delmia, everything we have. Now the thing is, what I found, as we are moving towards Industry 4.0, we are trying to eliminate the human component, which I think is one of the most important component everywhere. Because now with CATIA, our students are designing something, and with Simulia, they're getting some simulations and they're saying, okay, this product is absolutely fine. But when we are trying to implement it, we are finding that nothing is going to work. So in this Industry 4.0, if we focus more on software and technology, and we reduce the human intervention, then there will be a lot of challenges coming. So actually, this human part should encompass everything. So that is one of the major challenges that we have to always think of. What is your view?
So you have hit upon a very important idea. So we recognize the importance of automation. We totally recognize the importance of automation. But what we are looking at here, and you will see the digitally transforming enterprise, the digitally transforming enterprise is made up of digitally transforming human beings. So what we are looking at is technology and human beings working together in a cyborg form. There's a symbiotic relationship between the human being and the machines and the computer and what we are doing. That model is replacing this model of total automation, where you say, oh yeah, make the thing faster, quicker, better, cheaper. After some time, what happens with automation is that automation has to lead to a reduction in jobs. And after some time, guess what? That stuff gets outsourced or sent away to another country or something along those lines. The future is in looking at systems where the symbiotic relationship between the human, the computer system, and the physical system.
Right.
So Dipankar, at your institution, what you've come along and said, all right, I have a cyber system with computer tools, and they come up with a physical system, but hey, guess what? The human beings are not using their mind and their judgment to say, does this work or does this not work? Why? Because the computer system is not mature enough to make this happen. Now, with growing intelligence, this sort of stuff, certainly at some stage we could put it through a computer and say, all right, will this work or will this not work? So self-tutoring systems are an example of how we can get people to learn on their own.
Right.
Grammarly is another great example. You could go in and give your document to Grammarly and it comes back and tells you, hey, look, this is wrong, this is wrong, this is wrong. So we could have something like Grammarly put together for your students who would make this thing happen.
Taking it to a
Right.
higher level, you can think about this being the place that you see the interface between automation and human input. Because clearly there are some things that automation can do and be faster. And again, you identified that humans can do things. So where is the dividing line? And that dividing line, we believe, will change as we get more data, more information, and better models.
Right. Actually, for conventional or nearly conventional repetitive models, we don't need that much human intervention, but for other things, we absolutely need human judgment.
Thank you. Abhishek, you have your hand up.
Yeah, hi. So my comment is based on what Professor Debankar asked. That idea of human intervention is important, but I know for the future perspectives and for the validation, human is important. But besides that, could not capturing knowledge become a major source of that? Saying that my artificial intelligence does stuff what is given to it and it does very quickly. But if I have some knowledge engine in place wherein it is telling me, yes, this is right, this is wrong. So I'm still including another level wherein I probably need human only for the validation or for estimating or what is going to happen in the future, but not really what has already happened in the past.
You're quite right. Knowledge engineering that includes the capture of knowledge and the management of knowledge certainly is an extremely important element in this particular activity, and we have not touched upon it. I think, Janet, we need to make a note to bring this in. Knowledge engineering. Yeah, good point. I think we missed it in today's talk.
Yeah.
Thank you. Anybody else? Comments? Value to you? What it's got you to think? Yes, Devika. Go ahead.
So this was a very interesting talk, and what I feel personally is that in addition to IoT, we could also add a lot of computer vision now, because I find in industry, when we are talking about automation, we do require a lot of technology on computer vision, and which can be then connected to the neural networks and decision making. So that is one area I feel where maybe it is included when you talk about cyber physical systems, but just wanted to be sure about it.
Yes, let me tell you what we think about. We look at computers as a symbol processor, So it processes words, it processes numbers, it processes dots, mathematics, it processes pictures, it processes everything. So when we talk about cyber, we're including all these elements into it. And certainly computer vision is an extremely important element of the cyber system. So our view of computers is that it's a symbol processor. It's a symbol processor. And it's interesting to think, what if instead of the computer having gone on and processed numbers, which is what it was set up for because the banking industry picked it up first and adopted it, if the lawyers had picked it up and said, hey, we want to do word processing, would we have called it computers or would we have called it something else? It's interesting to contemplate what has happened out here. Other comments?
I have one comment. Hi all, I'm sorry that I'm running late. So Thank you for this wonderful presentation. And when I think about Industry 4.0, I think initially we have been looking in automation. We were looking into improving efficiency, reducing cost, improving quality, reducing time to market, and so on. But now I believe that we're more orientating toward human, and now human have a central role. And we're also looking at sustainability. So you will have a lot of these sustainable solutions that are in line with zero carbon economy. I think very interesting is, as we discussed that, I think a couple of weeks ago, humans have central role, and there will be this collaboration between a human and a robot. But this interaction will be interchanging in the sense at this point we will be teaching, we are not teaching yet, we will be teaching robots to do certain things, but that knowledge will be used further to help humans down the road. That is how I see. So I don't see this as something bad. I think that's a trend that is changing from automation to human role to sustainability, and maybe in the end to helping humanity.
So thank you, Yelena. Yelena is a co-author of the paper that we have cited actually, and that we've shared with you. Anybody else? Anand, Reza, Lin, Yanwei, Jacob, Hanbing, Rachel.
Yeah, I can go next, Farrokh. So, the two key ideas that I'm taking away from this talk is the idea of human cyber-physical systems, because even for my proposal, I was looking at it from a cyber-physical standpoint, but I guess the idea has to be tied to human, because it's a shared autonomy between the human and the computer. And the human plays the major role of making key decisions. So the human cyber-physical system, that paradigm is what is of interest to me. So second key idea that, that point that Janet spoke about, which is end-to-end digital integration. This is also something that I'm interested in, because when we are looking at manufacturing systems, we have to start from the initial, which could be materials, and end with the product, but the whole cycle has to be connected. So the end-to-end digital integration are the two key ideas that I'm taking away, and probably something that I'll look into add into my proposal. So thank you for that.
Prakash.
Yeah, so I will try to share a few of my thoughts. It's more of suggestion and observation rather than any concrete question, so to say. So what I observe is that because I have worked a little bit in the area of patentability and patenting and all that. So when you talk about a cyber physical system, the intellectual property is a part of the social, the business angle, because somebody has to make money in order to run a business. So we as academicians, at a very utopian level, we can say that we should develop a platform where everybody can collaborate, etc., etc. That's an utopian thought and very good. So we can have a Google of collaboration and all that. But industry people, normally the way in which they work is that they are cutthroat competitors and they want to kill other industries in order to win in the game. So now here comes a little bit of intricacy that people who are going to compete with another group. So we are talking about collaboration between a like-minded group who are going to compete with another group. So that's how industry works, because somebody will try to, Google came to power by killing companies like Lycos and Alta Vista and all those search engines which were there. So we have to somehow, being utopian is good, but we have to keep in mind for practical utility, somewhere there should be some provision for confidentiality, somewhere there should be a provision for patentability, somewhere there should be provision that these like-minded people are going to collaborate in a way that they are going to sign some sort of NDA. I'm not a fan of NDA, but I'm just telling that when we go and present this to industry, that's what is the question they will ask, that this is too utopian for practical implementation in industry. This is one observation. Another observation is that rather than, it's just an observation actually, I don't have a solution for that. Industry 4.0, you have rightly put it that it's co-creation, like it's designed by the people, but normally industry talks about, from 30 years back, we have been hearing about the technology push versus the user pull, so the market pull. But the way in which this has been there from 30 years, but market pull means sort of co-creation actually, because market pull is a user pain point. Like if you go and, I have attended so many of these venture capital seminars and meetings for trying to secure funding for some of the startups in which I was associated. So they will talk about this technology push and market pull and all that. But eventually the assumption somewhere, which openly people will not tell, assumption is that a user or a customer or a client, like an end user, like the person who really uses a technology, for example, precision agriculture. You told about precision agriculture, okay, farmer is going to use it, right? So in many cases, this user is considered without telling politely, it's considered as dumb, so to say, like they don't know to design. They can only tell their pain point, but they cannot co-create or design because they don't have the expertise to do so. You have to do either technology push or market pull. So this we have to keep in mind. I don't have a solution for this problem, but I think somewhere it may help if we can take that into account while formulating your Industry 4.0 definition, because that question will come sooner or later, because they don't have the necessary like imagination or critical thinking. That's why we are there, like so-called intellectuals. I don't consider that we are God, but they depend on the people to design solutions for them. So there we have to be a little bit careful and find out what level of user participation will be there. Because they may not know the technical challenge.
Let me push back on what you said, Prakash.
Yeah.
Let me push back on that. This is being offered as research collaboration. Research means the creation of new knowledge. Okay? That's what is offered. Once we have a product, the issues that you've talked about are important. At this stage, we do not have a product. What we are looking at is defining the space and saying this is the space in which we wish to operate. So this is a pre-competitive space. Industry has nothing to do with this. What we are looking at here is publications. What we are looking at here is educating the next generation of people to go and make this happen. So you're quite right in what you've said. If you want to proceed the way in which you are proceeding, then go and ask industry, what's your pain point? Set your institution up to address that pain point, and none of this is applicable or valuable because industry is operating in an old-fashioned way, and their pain points are brought about by their old-fashioned way of doing things. And so this doesn't apply. This just doesn't apply. So I think we need to be very clear in what this is about. This is research, the creation of knowledge, the ability to collaborate amongst faculty to make it possible for somebody to go to industry and say, hey, guess what? We have something along these lines. And just like Nastran that started off at NASA, and it was a free program that was available. Then it was formed into a company. It was spun off into a company, and now Nastran is a publicly owned company that makes things happen. So certainly that's a way in which you transfer technology. But this is not for transferring technology because we do not have the technology. This is for designing the technology to make it happen.
Okay, thank you. Thank you.
So Anybody else? We have 5 more minutes and then we can close. Reza, Jacob, Hanbing.
I have some takeaways. We've been working on studying on transitioning from a push economy to pull economy, which is based on customers. And today I got a clearer insight about what is a pull economy, which is based on customers' reviews, customers' insights, customers' choices, or even co-creation of a product with customers. And with my studies over online shopping, it becomes much clearer for me. Everything is going to be decentralized, even designing the applications, designing the softwares, and designing the products. So decentralization will be very important in the next generation of engineering design. I think blockchain will be very important because all the platforms or the process of the design will go through this decentralized platforms.
Reza, what's the point you want to make?
Yeah.
What is the point you want to make? You're giving me all the background. Tell me what point you want to make.
These are my takeaways.
Okay.
And I believe because social part will be very important, so environmental sustainability and low carbon economy also will be very important. And these are the things that I want to put in my I statement and work on it as when I become assistant professor, working with you on that part of the your neo research thread. Trust.
Thank you.
Thank
Haley, Salam, Jacob, Hanbing, Dipankar, Jiahong. Right? Hearing none. Closing remark. Next week, we're going to have Anand, Yelena, and Zenjun, who will be fostering the discussion on their views of evolving cyber-physical social systems. I understand each of them are going to present 2 slides, and we will then have a very interesting discussion in terms, a dialogue actually, in terms of where we are going, and what opportunities we have for research in this domain. Yelena, would you like to say a few words about your thoughts for next week?
Okay. Hi, all, sorry. So next week, yes, I'll present my view, so do show up. We have quite busy week here because it's end of semester. So I didn't give much thoughts, but next week I'll definitely prepare something. So I know my students will show up. I would like to invite everybody else to show up because Anand and will also prepare something.
Great. So, Jyoti, anything to closing statement?
Yeah, I can thank you. I can only thank both of you for initiating this collaborative platform, and we have been in touch, and we have developed something jointly in the recent past, and I would look ahead to continue that, and let us see how things shape up. Yeah, it's a very interesting area because it's multidisciplinary, and it transcends all disciplines actually, including management and social science and humanities. So, and it's very relevant because the social impact is very important for any technological research or development. So, I think we'll be in touch, doing something together.
Thank you.
Yeah, thanks.
Anybody else with a closing remark? Dipankar, Jacob, Abhishek, Hanbing, anybody? If not, Janet.
So thank you. Goodbye. Farrokh is already saying goodbye. So I appreciate your participating in this.
and the commentary and the discussion that we have had. So I look forward to seeing you all next week. All the very best.
Reza, we'll see you in a few minutes.